Many times, switches are used to control other electrical devices other than installed light fixtures. Here is a scenario where we see a receptacle at the end of a run and a regular single-pole switch positioned in the middle of that run. This switch controls the flow of electricity and power to the outlets at the end of the run. We often use this setup when we want to turn on or off a lamp or other plug-in device by using a switch instead of constantly unplugging and replugging in that cord. To make this work, connect the incoming hot wire to a terminal screw on the switch and connect the outgoing hot wire to the other terminal in this fashion. Connect the neutral wires with an appropriate sized wire nut and combine the ground wires as we've previously shown. Now, since this receptacle is located at the end of the run, connect the incoming hot wire to a brass terminal on the right side of the receptacle and connect the neutral wire to a terminal screw on the left side of the receptacle. Then, connect the ground wire to the grounding terminal on the receptacle. Once this is done properly, you can control anything you plug into the receptacle with a simple flip of the switch. It has become the practice of electricians in some areas to indicate these switch-controlled receptacles by turning them upside down when they are installed. This helps to differentiate them from other regularly wired receptacles. In our last example, we showed you the case where a switch-controlled receptacle was located at the end of a run. Another very useful scenario would be to reverse this setup and put the receptacle in the middle of the run and put the switch at the end of the run. This situation is called a switch loop. In a switch loop, the incoming cable arrives at a light or receptacle first before reaching the switch. To still be able to control this receptacle via the switch at the end of the run, you must wire this setup differently. This is how it should be done. We see here that we have a receptacle positioned between an incoming cable from the power source and an outgoing cable leading to the switch. Since we want this receptacle to be controlled by the switch at the end of the run, we must first send the incoming electricity to the switch, bypassing the outlets. If the switch is in the on position, the electricity will pass through the switch and then come back to the receptacle to give it power. Remember what we've discussed before. A receptacle is powered by connecting an incoming hot wire to a brass terminal on its right side. Understanding this helps you learn how to wire this switch loop properly. Let's start here. Since we know that the electrical current will be returning to power the receptacle from the switch, let's first connect this black wire to the correct brass terminal on the right of the receptacle. The current will want to pass out to a device, then return to the receptacle on its way to ground. So then to accomplish this, we connect the outgoing neutral wire to the left side of the receptacle. This leaves us with an interesting situation. Here we have an incoming black hot wire and a white wire that is the only thing left to deliver power to the switch. The National Electrical Code in this situation allows us to use this white wire to deliver the current to the switch. Connect the black incoming hot wire and the white wire leading to the switch with a wire connector. By connecting the white wire to the black hot wire, the white wire becomes a hot wire. When this happens, it is code that you must identify that a white wire has become a hot wire by flagging it with a piece of black tape, or by clearly identifying the white wire as hot by coloring it with a black marker. The incoming current will travel along the white wire until it reaches the switch. Connect this incoming white wire marked black to a brass terminal on the switch. Again, identify the incoming white wire as the hot wire by flagging it or marking it black. Then connect the black wire leading back to the receptacle to the other terminal. When the switch is in the on position, the current will travel across the switch and then back to the receptacle via the black wire. Notice again how we use the black wire as the hot wire to deliver power to the receptacle, just like we discussed earlier in our example with three-way switches. Wherever possible, always use a black wire as the hot wire when delivering power to a receptacle, light, or other electrical device. Observing this rule will help eliminate any confusion as to which wire is the hot wire if you ever need to make repairs in the future. It also maintains consistency with all your household wiring. Now, connect the ground wires together on both the receptacle and the switch. Once this is done properly, you will be able to control the receptacle by using the switch at the end of the run. What if the situation were to arise where you would like to control only one outlet on a receptacle by a switch, and the other outlet you would like to function as a normal outlet, always having power? Doing this is easy. Remember, both outlets can be powered by a single incoming hot wire being attached to one of the brass terminals on the right side of the receptacle. These tabs on the side of the receptacle allow electricity to flow from one outlet to the other. These tabs are removable by design to stop the flow of incoming current from one outlet to the other and to use each outlet independently. Simply take a pair of needle nose pliers and remove this tab. Now, incoming current will only affect the outlet adjacent to the nearest brass terminal. To see how to wire this scenario, let's go back to our previous example of the switch loop, where the switch at the end of the run is controlling the receptacle. In this case, we will choose the top outlet to be controlled by the switch, and the bottom outlet we will wire so that it will function as a normal live outlet. First, we will remove the right tab between the two outlets. This will prevent current on the top from passing to the bottom outlet. Next, we will add a pigtail. We will connect this pigtail to the hot wires connected here by the wire nut, and then we will connect the other end of the pigtail to the brass terminal adjacent to the bottom outlet. Now, if electricity were flowing through the circuit, it would arrive at this point and then pass down the pigtail into the receptacle's lower outlet. Then it would return back to ground through the neutral wire if a plug were inserted. At the same time, current would arrive at this point, continue on down the line until it reached the switch. If the switch were open in the on position, the current would pass through and continue back to the receptacle by this black wire, arriving at the top terminal of the receptacle. If something were plugged in this outlet, current would flow out and return back to ground using the neutral wire on the receptacle. Notice that since this tab is still in place, both outlets are using the same neutral wire to return the electricity back to ground. As always, if you're ever unsure how to wire any situation, be safe and contact a licensed professional electrician.
Some supplemental information to the switch loop that they show here. New code rules say that you have to have a neutral at each switch. And why you have to have that is because a lot of the newer devices like dimmers and motion sensors, etc., they need a neutral. And they need that for their internal circuitry to work. So instead of just running a 2-wire and identifying that white wire with black tape or black felt pen, as was acceptable in the past, nowadays they want you to have a 3-wire. Use the neutral as a neutral, then bring your power down likely on the black and then back on the red, although it's irrelevant as to which two of those hot wires you use. It's good to keep in this lesson though, because there are many switch leg loops out there, and that trips up people hundreds of times, and I get lots of questions on why do I have a white wire that's hot in my switch box. So that answers that for you.